I want you to close your eyes for a second, unless you're driving, of course, please don't do that, and picture a scene that humanity has been obsessing over for thousands of years.
Oh, I think I know where you're going with this.
It's from Greek mythology. There's a man at the bottom of a steep, rugged hill. He is sweating. He is straining. Every muscle is just screaming as he pushes this massive boulder up the slope.
He fights for every single inch.
Every inch. He gets it halfway up, 3/4. And just as he's about to heave it over the top, his strength fails. The boulder slips. And it rolls all the way back down.
And he has to walk down and start all over again. Sisyphus.
Sisyphus, the man condemned to futile labor for eternity. Now, usually we use this as a metaphor for, I don't know, trying to keep your email inbox empty.
We're doing laundry, yeah.
Yeah.
The daily grind.
But today, we're doing a deep dive into a brand new paper that suggests this myth is actually the perfect economic model for one of the most controversial strategies in fighting climate change.
It is a striking comparison, isn't it? We're looking at a paper published just a few days ago, January 21st, 2026, by Max Franks and his colleagues at the Potsdam Institute. And the title, it tells you everything you need to know. Pigou's advice and Sisyphus warning.
It sounds like the start of a very intellectual joke. An economist and a mythological prisoner walk into a bar
To argue about the end of the world. And in a way, they did. Their subject is carbon dioxide removal, or CDR, but specifically the non-permanent kind.
The kind that might roll back down the hill.
Exactly.
Okay, let's unpack this, because usually when we talk climate, we talk about cutting emissions. Stop burning stuff, solar panels, wind turbines.
Right. But the sources we're looking at today are all about the other side of the ledger, sucking carbon that's already out there back out of the atmosphere.
And to set the stakes here, because they are incredibly high, the source material says that to limit warming to 1.5 degrees Celsius, we might need to remove up to 20 gigatons of CO2.
Annually. In the second half of this century.
20 gigatons. That is a number so big, it's hard to wrap your head around.
To put it in perspective, that's roughly half of what the entire world emits today. So we're talking about a massive, massive undertaking.
Scrubbing the atmosphere on a planetary scale.
We have to. And so we have to push this boulder up the hill. But the catch, and this is Sisyphus's big moment, is that not all storage is created equal. Some places we put that carbon are forever, and some are, well, leaky. And the mission of this deep dive is to answer a really uncomfortable question the paper raises. Is this temporary storage planting trees, trapping carbon in soil? Is it a valid solution? Or is it an economic trap?
Are we just pushing the boulder up the hill only to watch it roll back down on our grandchildren?
That's the question.
That is a heavy question. To understand the trap, though, we have to understand the landscape. The paper draws a pretty sharp line between permanent and non-permanent CDR.
Right. Let's start with the permanent side. This is mostly geological storage.
Think direct air capture, those giant fans you see in articles.
Exactly. Sucking CO2 out of the sky and then injecting it deep underground into, say, basalt rock formations. Or BCCS bioenergy with carbon capture.
So this is the lock it away and throw away the key approach.
That's a perfect way to put it. The source notes that this kind of storage lasts for millennia. It effectively turns to stone. For all economic purposes, it's permanent.
Okay, sounds great. So why aren't we just doing that?
Because it's currently incredibly expensive. And technologically, it's really hard to scale. We just don't have the infrastructure yet.
So because the perfect solution is too hard or too expensive right now, we're looking at the other bucket, the non-permanent stuff.
This is what you see in all the corporate press releases.
We planted 1 million trees.
Right. Nature-based solutions. Afforestation, reforestation, soil carbon sequestration. But the authors also include a category that I found, well, honestly, a little surprising. The product sphere.
The product sphere. That
Yeah.
sounds like a buzzword from a tech conference, but in the paper, it refers to my furniture.
It does. It refers to things we make. Wooden buildings, furniture, even bioplastics. If you build a house out of timber, that wood is holding on to carbon that was once in the atmosphere.
But the house doesn't last forever.
And that's the whole point. That's the crux of the non-permanent label. The paper lists the half-lives of these methods, and the differences are just wild. Geological storage, thousands of years. A single-family wooden home, maybe 100 years.
And I'm looking at this table in the source paper products. It says 2 years.
2 years. So if your plan is to capture carbon by turning it into a cardboard box, you haven't really solved climate change. You've just, paused it for 24 months. Eventually,
Yeah.
that carbon goes right back into the air. It leaks.
And soil carbon, which gets a lot of hype and lasts for years, maybe decades. But if you just till the field one time, poof, it's gone.
Right, so here's the tension the authors are pointing out. We have a pretty good idea of how to tax fossil fuels. That's the Pigou's advice part of the title.
Hmm.
You tax the bad thing.
If I tax your factory for emitting smoke, you figure out a way to emit less smoke. Simple incentives.
Exactly. But Pigou didn't really tell us how to regulate a good thing that eventually turns back into a bad thing. If I stop a ton of emissions today, that benefit is permanent. It's gone from the ledger. But if I remove a ton of carbon by planting a tree, and that tree burns down in 30 years,
The benefit was just a loan. You have to pay it back.
it was a loan. So is it even worth doing? I mean, if the boulder just rolls back down, why start pushing?
And this is where the paper delivers its first big surprise, because you'd think the answer would be don't bother.
You would. But the finding is that, yes, using non-permanent CDR is actually welfare enhancing.
Welfare enhancing. So despite the leak, it actually makes us better off.
It does. The model shows that temporary storage acts as a kind of bridge technology. It reduces the overall cost of fighting climate change, but specifically during the transition.
Okay, I can see that logic. It's cheaper to plant a forest today than it is to build a massive direct air capture plant.
Much cheaper.
So we plant the trees to hold the line, to keep the temperature from spiking too fast, while we wait for the permanent tech to get cheaper or for the grid to switch to renewables.
That's it, exactly. It smooths the transition, it keeps costs down in the short run, but, and this is a huge but, it creates what the authors call a carbon debt.
The debt. This is where Sisyphus enters the chat.
Think about it. If you store carbon in a forest to meet your climate goals, you are making a commitment. You're on the hook. And if that forest dies or decays, releasing the carbon
You have to remove it again to stay carbon neutral. You have to push the boulder back up.
forever. The paper explicitly warns that in the steady state, meaning the long-term future where we stabilize the climate non-permanent CDR provides, and this is a direct quote, zero net removal.
Zero. That seems so harsh. How can it be zero?
It's just the math. If the storage is leaky, then eventually the rate of leakage equals the rate of removal. So its only job in the long run becomes recapturing the carbon leaking from the stuff we stored in the past.
We're leaving future generations a maintenance task. We're handing them the stone and saying, hey, whatever you do, don't let this roll down.
That's the Sisyphus warning. It's a massive moral hazard. We get the cheap benefit now. We get to say we did something, and our great-grandkids get the perpetual bill for cleaning it up.
That is deeply uncomfortable.
And there's another finding in here that really threw me for a loop. They call it the independence result.
Yeah, I circled this in the notes because it felt so counterintuitive.
It's fascinating mathematically. The paper finds that the availability or cost of non-permanent CDR does not change the optimal long-run temperature target.
Okay, break that down for me. Because I would assume that if we have a really cheap way to suck carbon out of the air, like planting trees, we're going to aim for a cooler planet, right?
Could be more ambitious.
Instead of 1.5 degrees, maybe we shoot for 1.4.
You would think so. But the cost-benefit analysis in the model says no. Cheaper temporary storage doesn't mean we aim for a cooler planet. It just changes how we get to the target we already picked.
So we just use the cheap trees to delay doing the hard stuff.
Effectively, yes. It changes the path, not the destination. And the model shows that if we rely heavily on non-permanent storage now, it often leads to what they call an overshoot scenario.
Overshoot, meaning we go past the temperature target for a while.
Exactly. Imagine we're aiming for 1.5 degrees. If we use a lot of leaky storage, the model suggests we might let the temperature peak at, say, 1.6 or 1.7 degrees, with the plan to scrub the atmosphere later and bring it back down.
That sounds incredibly risky. It implies we can use more fossil fuels now.
It does. Cumulative emissions actually go up because we're banking on this future cleanup.
It's the classic diet analogy. I can eat this cake now because I promise I'll run an extra 5 miles next month.
Precisely.
Mhm.
And if you get injured and can't run next month, that's the risk. If that permanent removal tech doesn't arrive on time or isn't as cheap as we hope, we're stuck with the extra heat and a bunch of leaky forests.
Okay, so this brings us to how we actually measure the cost. We talk a lot about the SCC, the social cost of carbon. That's the damage done by putting a ton of CO2 into the air.
Right. Usually called SCCE for emissions. But this paper introduces a new metric that I think is going to be very important.
Yeah.
The SCCR.
Social cost of carbon removal.
Yes. And you can think of it as the cost of the future release. It's the damage that will be caused when that stored carbon eventually leaks back out.
So the value of a temporary tree isn't just 1 ton removed. It's 1 ton removed minus the damage it will do when it eventually rots.
Exactly. The value is permanent storage minus the SCCR. But there's another variable they introduced which I found really insightful: diligence.
Diligence, like just being careful.
Like active maintenance. Storage isn't passive. You don't just plant a forest and walk away.
Hmm.
You have to prevent fires, monitor for pests. You have to irrigate.
And that costs money
Hmm.
continuously.
Yes, that's the IDC intertemporal diligence cost. And the paper argues that removal and diligence are complements. If you're going to do a lot of removal, you must also invest heavily in diligence.
You shouldn't buy a classic car if you aren't going to pay for the garage and the oil changes.
Perfect analogy.
Yeah.
And here's the kicker. The paper finds that if the diligence cost is too high, you shouldn't even bother with the removal in the first place.
So how do we fix this? How do policymakers design a system that doesn't just kick the can down the road? The paper lays out a policy menu.
They propose 3 main ways to handle it, and each one tries to solve that who pays for the leak problem.
Okay, let's start with option 1, downstream pricing.
This is the theoretically perfect solution. The government pays a firm a subsidy when they remove the carbon.
And then you tax them when it leaks back out.
Simple enough. I plant a tree, I get a check. The tree burns, I write the government a check.
It works on paper, but what's the catch?
The catch is something called judgment-proof firms.
Judgment proof.
It just means they go bankrupt. Imagine a company plants 1 million trees today. They get the subsidy. 50 years from now, the forest burns down. But the company went out of business 20 years ago. Who pays the tax on that leak?
The taxpayer.
The taxpayer. The risk is socialized. The paper suggests things like carbon bonds or insurance to fix this, basically, making them put money up front. But that's a lot of capital.
Okay, so if we can't trust the company to be around in 50 years, what about option 2, upstream pricing?
This one's interesting. You still pay the subsidy up front, but you apply a discount. You assume it's going to leak, so you pay them less from the start.
So instead of getting, say, $100 for a ton of carbon, I might only get 60 because the government calculates that some of it will leak over time.
Correct. The formula is roughly the social cost of carbon minus that SCCR we just talked about. The government takes on the risk, so they don't have to chase bankrupt firms in the year 2080.
But the downside seems obvious. How on earth do you know how much to discount? And what about diligence?
That's the problem. If you pay me up front, even a discounted amount, what's my incentive to protect that forest from fire next year? I've already got my money. The check is cleared.
Right. Why would I spend my own money on fire marshals?
You wouldn't. So the paper suggests you'd need really strict regulations alongside the subsidy to force companies to do the maintenance. It gets complicated.
Okay, option 3. This one felt the most logical to me. The stock subsidy. The rental model.
Right. This treats carbon storage like a service. The government pays the firm a fee every single year that the carbon stays in the tree.
Like renting a storage unit. I pay you as long as you keep my stuff safe.
Exactly. And if the forest burns down, the payments stop immediately.
And that solves the diligence problem, doesn't it?
Yeah.
I have a huge incentive to stop the fire because that fire is literally burning up my paycheck.
It creates a very strong incentive. It aligns everything perfectly. But the downside is cash flow.
Ah, right. It costs a lot to plant a forest up front.
And if you're the company, you have to spend millions to plant and build. But the payments only trickle in year by year. You could run a deficit for a very long time.
It's the classic startup valley of death. It would be hard to find investors for that.
Very hard.
Yeah.
And for all of these options, you have the problem of MRV, monitoring, reporting, and verification.
Yeah, the paper mentions this. Tracking a geological vault is one thing. You put a sensor on it. But tracking a wooden table for 30 years?
Or tracking soil carbon across millions of acres.
Uh-huh.
How do you know the farmer didn't till the soil? The administrative burden, the sheer bureaucracy of it all, is significantly higher.
It really feels like we're walking a tightrope here. On one side, we need this removal. The paper is clear. It's welfare enhancing. It makes the transition cheaper.
Absolutely. We cannot let the perfect be the enemy of the good. If these solutions can buy us 20 or 30 years of lower temperatures while we decarbonize, that's incredibly valuable.
But on the other side, it is not a get-out-of-jail-free card.
That's the synthesis. That's what the authors want us to take away. Non-permanent CDR is a tool, but it's a dangerous one if we misunderstand what it's for. It creates a liability for the future.
And it doesn't change the destination. That independence result really sticks with me. Planting trees doesn't mean we can stop worrying about the final temperature target.
We cannot plant our way out of this. Eventually, the physics demands that we stop adding carbon and start permanently removing it. The temporary stuff is just a loan.
And like any loan, it has to be paid back.
With interest.
Yeah.
And in this case, the interest is the diligence cost, the eternal maintenance.
It brings us right back to Sisyphus. I'm thinking about that image. The paper suggests that by using temporary storage, we are choosing to push that stone. We're buying time today by agreeing to push the stone tomorrow.
And the ethical question is, do we have the right to sign our grandchildren up for that shift? We're building an economy that relies on paying back a carbon debt forever.
It makes you look at those net zero pledges a little differently, doesn't it? When a company says they're carbon neutral because they protected a forest.
You have to ask, for how long? And who's paying for the fire patrols in 2050?
Next time you see a headline about nature-based climate solutions, take a moment to look at it with that critical economic eye. Is it a permanent fix, or are we just renting a little bit of time?
And remember, renting is fine, as long as you know the rent is due every single month, forever.
That is a thought to chew on. Thanks for joining us on this deep dive.
Always a pleasure.
We'll see you next time. And in the meantime, keep pushing that boulder, or maybe, better yet, find a way to make it stay put.